Okay, and next, now the last team of this morning session, I present to you Team Circuit Breakers. They will give a presentation on a proposal of the amendment about SOLAS for ensuring fire safety in electric vehicles during sea transport by ships. Let's take a look at the introduction
been closely
video.
related to our lives ever since the rise of the humanity. However, international trends have detected a rise in marine environmental degradation and accidents. We are facing more turbulent changes than ever before. That is why we ponder, we elaborate, we resolve. We are Team Circuit Breakers.
So, good afternoon, honorable judges and distinguished delegates. We are Team Circuit Breakers, and we are here to propose the importance of establishing safety regulations regarding electric vehicles. Our proposition is composed of 4 parts: the background behind electric vehicles, analysis of why the current regulations are insufficient, and our solution for the problem, and a conclusion combined with anticipations. Let us begin with the background. There's a reason that made us consider this topic so urgent. According to these graphs, you can tell that the market share of electric vehicles is constantly rising and is projected to increase even more. Since transportation of vehicles through airlines has limitations, it is logical to think that there will be a constant increase in the demand of electric vehicles shipping. While the market share of electric vehicles keep increasing, there's a major risk factors of shipping electric vehicles. A typical electric vehicle fire starts with a rapid rise in temperature of the lithium-ion battery, allowing only a short period of time to react. At the same time, the absence of pre-ignition symptoms significantly raises the difficulty of fire prevention. Moreover, the biggest obstacle in extinguishing electric vehicle fire is the reignition aspect, which is a phenomenon of reigniting even after it has been extinguished. These distinct features of electric vehicle fire makes our proposal so urgent. Based on the trend described earlier, we can tell that the demand for transporting electric vehicle is clearly going to rise while safety issues are unresolved. And if these hazards remain unresolved, we might face even more accidents, such as the recent PCTC tragedy on the screen, which caused massive material damage and human injuries.
So far, we figured out that the market share of electric vehicles are increasing, and that we lack safety regulations currently. In the part, let's take a closer look at why the lack of safety regulations is problematic and what efforts have been made outside of the neighbor industry. So, what discussions has IMO had regarding electric vehicles, vehicle fires on RoRo ships? According to the record of past IMO meetings, there has been 3 discussions on this matter, involving the subcommittee SSE and the committee MSC. In SSE, representatives from China and Panama urged the establishment of safety regulations for electric vehicle fires on RoRo ships. In MSC, there was a consensus that new safety regulations should be developed for RoRo ships, transporting vehicles powered by new sources of energy such as electricity. Even though there has been 3 discussions, only the necessity of establishing new safety regulations was addressed, and there was no discussions on the actual establishment of regulations or specific plans for implementation of the safety regulations. In order to seek for a solution, it is important to understand the structure danger of electric vehicle batteries. Most electric vehicle batteries are placed under the Baker for energy efficiency and design efficiency, to protect the battery from foreign substances while driving. It is enclosed in a watertight and a dust-proof steel cases. However, when it comes to shipping these cars, these aspects of design cause difficulties in suppressing fires. The graph on the left shows the amount of water used and inner temperature of the battery when extinguishing an electric vehicle fire using a conventional firefighting apparatus. Despite using 5,064 liters of water for approximately even 80 minutes, the inner temperature of the battery pack remains around 400 degrees Celsius and is still not enough to achieve complete extinguishment. This indicates that using conventional firefighting methods are insufficient in the problem of dealing with electric vehicle fires currently. Additionally, due to the nature of lithium-ion batteries that make up the battery pack, there is a phenomenon called thermal runaway, which, even if the fire appears to be extinguished initially, reignition can occur after some time. Looking at the graph again, we can observe that during the first 80 minutes, the inner temperature of the battery pack seems low and kept low due to the firefighting efforts from first time. However, after 80 minutes, there is a rapid increase in the temperature and indicating a reignition. Because of this extremely high risk associated with electric vehicle batteries, special methods are needed for firefighting, rather than just relying on a conventional firing apparatus and classic techniques. The fire department has been researching these issues for a considerable amount of time on land already. Currently, they have successfully developed an effective electric vehicle fire suppression manual by combining the 3 pieces of equipment shown above in a specific sequence. In addition, as autonomous ships emerge, there is a automatic fire extinguishing system on land, in case no one is on board. This is a robot dedicated to extinguishing electric vehicles, which automatically recognizes and extinguishes electric vehicle fires in an event of catastrophic fires. Also, there is another equipment that can be used on autonomous ships. Let me briefly introduce you to a small drone which can be prepared for fire through a thermal sensing system. However, these 2 equipments are currently difficult to apply due to the time and technical limitations. Upon reviewing this data graph, it is evident that when using conventional firefighting methods such as water, the temperature hardly changes even after prolonged applications, making it nearly impossible to extinguish, as previously confirmed. However, when using the dipping tank for suppression after the initial firefighting process, we can observe a significant temperature drop to the near room temperatures in just 10 minutes, effectively achieving complete suppressions.
We've also conducted an economical analysis. The cost of introducing all the equipment is approximately $30. In contrast, recent estimation for losses due to PCTC fires caused by electric vehicle converts to $438 million, suggesting that minimal investment in the equipment can prevent us from facing enormous economic damage. When IMO proposed regulations, it conducts an assessment based on risk
Analysis and Cost Effectiveness Evaluation called FSA. Based on this FSA, we analyzed the cost benefit by adding an item called the introduction of electric vehicle fire equipment to risk control options. It is used as an example. And we analyzed the cost benefit by comparing a method of increasing the number of crew members for fires, which is an A3 items previously listed on risk control option named RCO, and the introduction of electric vehicle fire equipment. A comparative analysis of the benefits using the cost-benefit assessment, named as CBA model, shows that introducing vehicle fire is about 6 times more cost-effective than increasing the number of crew members. Now, let's discuss the equipment modification and detailed solutions extinguishing electric vehicle fires. Firstly, we have made new regulation for electric vehicle fire equipment under SOLAS to the IMO Committee, MSC, and Subcommittee, SSC. We suggest the addition of supplementary regulation under Rule Number 6, Fire Extinguishing in SOLAS Regulation 20, which deals with the protection of vehicles, special categories, and road spaces. To make this ease of understanding, we have created an example. We have added provision under Rule Number 6 Extinction that details the placement of firefighting equipment and make it mandatory to install the previously mentioned special firefighting equipment, namely pocket-type dipping tank, fire blanket, and electric vehicle fire extinguishing nozzle. These clauses have been developed by referencing the specifics of other regulations under SOLAS Regulation 6, such as portable fire extinguishers. Secondly, we propose detailed specification and requirements for special firefighting equipment in the FSS code. As there are currently no provisions in the FSS code related to electric vehicle fires and their associated special firefighting equipment, we suggest adding a new chapter. An example of the FS code amendment we propose goes through these followings. We provide detailed definition for the following apparatus. Furthermore, we specify the dimension and usage guidelines for each firefighting apparatus. In addition to the proposed amendment outlined so far, we would like to address the milestones for practical implementation in the field. Until the overall market share of electric vehicle fire reaches 50%, we recommend these provisions. However, when it exceeds 50%, we propose making these provisions mandatory. This milestone is intended to soften the burden on nations and enhance the visibility of the proposal. Finally, we will move on to our conclusion.
So far, we took a look at the current problem and suggested how amendments to the regulations actually work, but simply changing regulations has limitations. Further systematic education and training processes are necessary, along with amending regulation. Therefore, we propose that the content related to crew education and training on electric vehicle fires be additionally discussed on Model Course 1.2, revised under the STCW Convention of IMO. Discussions related to this matter are held at the Expert Group Subcommittee HTW and the Committee MSC. We hereby suggest further discussions on this content within these committees. If our proposal is accepted, the expected effects would align with IMO's goal of adhering to ESG and achieving the following 6 items in the SDG objectives. Furthermore, in addition to the IMO's strategic direction on the right, safety regulations for electric vehicles can be secured on SDG 2, so that crew members can appropriately be educated to prevent human error. We have many more steps to take, but we strongly believe that the gradual introduction of regulations at an appropriate level will increase the efficiency of our industry itself. Finally, in Korea, there's a saying, one fire extinguisher at the beginning of the fire is equivalent to 1 fire truck. This expression emphasizes the importance of fire extinguishers on land. Similarly, We believe that just as the distribution of a single fire extinguisher on land brought massive effect on fire prevention, our small-scale discussion aimed at preventing fires on large ships will make a significant progress as well. We were Team Circuit Breakers, and thank you for listening.
Okay, thank you very much, Team Circuit Breakers, for the nice presentation. And we're gonna have Q&A session. Okay, Dr. Nam, please.
Okay, congratulations to your excellent presentation. But I want to seek one or two clarification from your idea. Looking at slide number 4, you assumed that with increasing number of EV, there will be also increase in fire. But have you ever tried to find out if this EV fire is more frequent compared to petroleum car fire?
Thank you for your question, but I believe even though it is frequent or not, the main reason that we want to propose this amendment is because the EV fire is really hard to extinguish. For that, the conventional cars that we used to use aren't that of a much deal. However, right now, as many research examples show, EV fires can cause a farther much more damage compared to conventional cars. That's the main reason, and we actually didn't get a chance to actually find out any more details about that.
Yes, I totally agree with you. It is very difficult to suppress once the EV car catches fire. But what if the rate of catching fire is less than 10% compared to petroleum fuel-based car? Should we still have to have this kind of a mandatory requirement in IMO regulation?
Thank you for your idea, first of all. But we have already made a research on land that conventional cars have actually a very similar amount of percentage with the electric vehicles. So, and also, if the actual accident percentage is less than 10%, we still think this should be amended, because from that 10%, that can cause a much more damage to the shipping itself. For example, the cost amount that we have shown at the PPT presentation has already shown that it has about $300 million of the economic damage. So I think we still need to amend this amendment. Thank you.
Okay, that's very convincing. I would like to make one more clarification in slide 17. It's very interesting to see you guys conducted the FSA, and in this scenario, you assumed fire explosion, and your approach is once the fire is there is a fire, you suggested prevention measures and mitigation measures in your proposal. But if we see this risk, this issue from different angle, if we can reduce or if we can eliminate the risk of catching fire, for example, most of EV fire, the major cause of EV fire is overcharging of battery. If we limit the charging rate of battery, let's say 20% or less than 50%, it dramatically reduces the possibility of catching fire. Then it can solve. We can eliminate the risk. Then we don't have to control the risk. Have you ever considered this kind of approach?
Thank you for your idea. Can you give us some time to think about this idea? Thank you for your idea. We believe that your idea is actually true. There are limitations that we can actually just make the battery decharged so accidents do not happen. So that's one of the limitations that we have figured out during making this presentation. So we think we should make a further discussions on IMO related to these kind of batteries. Thank you.
Okay, thank you. Dr. Nam pointed out very important ideas, so I want you to think about it later. And next, let's take a question to Mr. Seo.
Thank you. In line with Dr. Nam's comment, I will update for you. 2 months ago, we have a technical seminar with PCD carriers. The car manufacturers, we are using the word SOC, the status of charging. The manufacturers, they wish more charging of the batteries, but to mitigate any burden, any fire risk, the charterers and ship owners, they wish to less than 30%. This is an ongoing issue. Thank you. I have a quick comment on slide 5. You've addressed the 3 factors of lithium-ion batteries. The number 1 is thermal runaway. Number 2 is no symptom. And number 3, reignition. In recent research shows that in the case of lithium-ion batteries emit off gas. In detail, between 80 to 120 degrees Celsius, it emits C2H4, ethylene, CO2, carbon dioxide, and above 120 degrees Celsius, it emits CO, carbon monoxide, and C2H4, and also CH4 methane. I advise you update this slide. Thank you.
Thanks for your idea. And I think we can take one more questions on the floor. Maserati, please.
Thank you for your presentation. You mentioned special equipment for extinguishing fires in electric vehicles. And it's expected that it will be difficult to use the equipment due to the narrow cargo hold space when we think about the nature of the car carrier. So how will you respond to this?
Thank you for your thoughtful questions. Okay, so actually, we are already well aware of difficulties involving in extinguishing fires in narrow cargo hold. So special equipment such as hydraulic pumps and hydraulic devices, as far as I know, are still in full swing to distinguish an electric vehicle fires in small spaces already in inland. So therefore, for that matter, I think that the above problems can be solved by the development of technology in the future. So if only the basic equipment is drafted. So thank you.
And also, I would like to give you an idea that we want to discuss about this at the IMO, that we should actually amend to make a much longer distance between the cars on the PCTC. We know it is a very is a damage on economically for the companies, but we think everyone's cooperation is needed to make further incidents don't happen. Thank you.
Okay, time is up. Thank you so. Okay, Captain Kwok, please.
Page 16, the cost for the firefighting equipment estimated $30,000. I think now at the moment the standard car carrier is 6,000 units or 8,000 units. So you place the equipment each of the car deck. So 30,000 is very unrealistic, I think. Thank you.
Okay, thank you very much for your comment. Did you guys get it?
Yes, thank you for your idea.
Thank you so much. Everyone, please give them a big round of applause.